Okay, so some of you requested that I do some additional examples similar to some of the questions on the mixed practice. And so I have here 10 additional problems that I am going to work through, and then I'm also going to give you an additional problem for you to do. And then if you would like to check your answers, reach out to me for those, and I can give those answers to you. So, um, the first one that we are going to do, let me find the mixed practice here so that I can um, compare it to that. Um, so the first one is like number 3 on the mixed practice, okay? And so the first one I'm going to do is I want you to simplify the square root of 24 divided by 25y squared. Okay, and anytime that you see a negative on the outside of a square root, it's just going to stay on the outside. Nothing can happen there. And then when you have a square root and then a fraction, you have two options. You can either see if you can simplify what's underneath, or you can go ahead and break up the square root into two square roots. And in this case, that's what we're going to do because 24 and 25 cannot be simplified. So we're going to then break this up into the square root of 24 divided by, and then on the bottom, the square root of 25y squared. Okay? And now we can look at those as each individual radicals to be reduced. And so we've got 24, and 24 breaks down in a couple different ways. I'm going to break it down into 6 and 4. 6 breaks down into 3 and 2. 4 breaks down into 2 and 2. And so we can break 24 down into 3 times 2 times 2 times 2. And then 25 can break down into 5 times 5, and then y squared breaks down into y times y. And so then we can pull out pairs. So there's a pair of 2's. So we keep the negative from the outside. We have a 2. And then left underneath, we've got 3 times 2, which is 6. And then on the bottom, you've got a pair of 5's and a pair of y's. So then you just have 5y. And then the last thing that you look for is to make sure that nothing else can be simplified. And here, nothing else can be simplified. The 2 and the 5 don't simplify. You can never simplify what's underneath the root with what's on the bottom. So this would be our final example here, or a final answer here, okay? And so a practice problem like that would be for you to simplify negative square root of 54 divided by 16x squared. Okay, so that's the practice problem like that. Okay, let's do one like number 4 on the mixed practice. And so practice or example 2 for us would be to simplify 3 divided by the square root of 5x. Okay? Now, 3 and 5 can't simplify for a couple different reasons. First of all, 3 and 5 don't have any factors, but also the 5 is underneath the radical, and we can't have radicals in the denominator, and so we need to get rid of that radical in the denominator by multiplying it by itself, and whatever we must do to the bottom, we must do to the top there. Okay? And so when we do that, we multiply across. We cannot take the 3 inside there. That doesn't work. So that just stays as 3 times the square root of 5x. Okay? And then down here, if you want to take this step, well, that becomes the square root of 25x squared. But then that just simplifies down to 5x. Okay? So you can either take this intermediate step or not. You may be able to jump right there to that conclusion, and that's fine. Okay? So on the quiz, what I would need to see is, oh, yeah, you know how to multiply the top and the bottom by whatever rationalizes that denominator. But you don't have to take this intermediate step if you know that this is just going to create a denominator of 5x. Okay? So the practice problem like that you could do is 4 divided by the square root of 3y. Okay, so contact me for those answers if you wish. Okay, number 3. So number 3 is I want you to simplify the square root of 2 divided by 8 plus the square root of 5. And now we have a different type of rationalization here because now we've got a binomial in the denominator. And anytime that you had a binomial in the denominator, you had to multiply by what we called the conjugate. And whatever we did to the bottom, we must do to the top there. Okay? And so when we do this, now we can multiply. So the square root of 2 times 8, well, you can't combine those, so that just stays as 8 times the square root of 2. Okay? And then the square root of 2 times the square root of negative 5, well, that's negative. And then this is an opportunity where you could multiply underneath. So the square root of 2 times the square root of 5 is the square root of 10. Okay? And then divided by, well, now we've got a foiling problem. So 8 times 8 is 64. 8 times negative root 5 is negative 8 root 5. That becomes a positive 8 root 5. And then positive and a negative create a negative. And 5 times 5 is 25. So now we just got to clean this thing up. So this becomes 8 square root of 2 minus the square root of 10 divided by, and then 64. The negative 8 root 5 and the positive 8 root 5 go away. And then minus the square root of 25 is 5. And then the last thing that we can do here is do 8 square root of 2 minus the square root of 10 divided by, and then that becomes a 59. And then that's where we stop. We can't do anything else because there are no common factors between those 3 terms. Okay? So the practice problem like that, practice problem 3, would be for you to do the square root of 5 divided by, let's do 3 plus the square root of 2. Okay, simplify that. You're going to have to rationalize by multiplying by the conjugate. Okay? Great. So those are all the examples in terms of simplifying radicals. That was section 9.1. And so hopefully that helped. I know that was a while ago, so maybe just hearing it again. If you were very lost there, go back and watch the 9.1 video again. Okay, I think sometimes rewatching helps. Moving on. All right, number 4. We are going to do a couple where we solve by factoring. Okay? So we are going to solve by factoring x squared minus 5x minus 14 equals 0. Okay? And so the first thing we look for is a GCF. We don't see one. So then we set up our skeleton of x and x. And we need 2 numbers that multiply to negative 14, but add to negative 5. And that gives us a 7 and a 2, and that would be a negative 7 and a positive 2. So then we set x plus 2 equal to 0, and x minus 7 equal to 0. So then we can say x equals negative 2, and x equals 7. Okay? That one is a lot like number 12 on the mixed practice. All right? So the practice problem that pairs nicely with that one is solved by factoring x squared plus 6x plus 5 equals 0. Okay, so there's an additional problem like that. Contact me for that answer. Okay? Number 5. Again, we are going to solve by factoring. Okay? And so we're going to solve by factoring 16x squared minus 8x plus 1 equals 0. And this looks a lot more difficult, but it's actually not. Again, we look for a GCF. We don't see one, and so we set up our skeleton. Okay? And then we know, because this is a 1, that you got to have, ones on the ends. And then we're like, all right, well, 16x squared, there's a couple different ways we could get there. Usually, in a case like this, if it looks like if it can be divided into two equal parts, then try it. Let's try 4x and 4x. We know there has to be two negatives because this is a negative and that's a positive. And so that 16x squared, let's see, minus 4x do get us back to negative 8x. Good, so I guessed right. Okay. And then this is nice because these are both the same factors. So now you only have to set one of them equal. So 4x equals 1, x equals 1/4. Okay. So that one's nice. A practice problem like that one, practice problem 5, would be to solve by factoring 4x squared minus 8x plus 4 equals 0. Okay? You can actually solve that one a couple different ways in terms of the factoring of it. So anyway, contact me for that answer if you want it. Okay? You can also check your answers by graphing. Number 6, solve by factoring. Again, last one here. Solve by factoring. This time we're going to do a 3x squared plus 5x equals negative 2. And the first thing I think that we should probably notice is that it's not set equal to 0, and so we need to set it equal to 0. So we do 3x squared plus 5x plus 2 equals 0. And now we look for a GCF and we see that we don't see one, and so we set up our skeleton. Okay, and so that can be a 3x and this can be an x, and we know that we need to get to 2, so we need 2 and 1, and I see that I have 5, and I know that I can get to 5 by doing a 3 and a 2. So that's the correct factoring right there. You can always check your work, of course. So now we set 3x plus 2 equal to 0 and x plus 1 equal to 0. So 3x equals negative 2, x equals negative 1. So that's where we can stop there. And x equals negative 2/3. Okay? My guess is your issues with the solving by factoring don't have to do with any of the solving, but with the actual factoring part. Okay? So practice problem 6, I want you to solve by factoring 7x squared plus 10x equals negative 3. Okay, you do that one. All right, number 7 here. We're going to solve by square rooting, but that's pretty apparent here when I write this one out. Let's solve negative 2 times x plus 4 squared equals 10. Okay, and so we want to get x by itself. So the first thing we're going to do is divide by negative 2, divide by negative 2. So we have x plus 4 squared equals, that turns out to be a negative 5. So then we square root, and you're left with x plus 4 equals plus or minus. Well, you can't take the square root of a negative, and so this is where you would stop. And you would write the words no real solution. And make sure you have that word real. It matters. Okay? So this would be an example of where we had no real solution. Okay, so practice problem 7 then would be for you to solve 3 times x plus 4 squared equals negative 12. Okay, there's a similar problem. Those, by the way, match with number 17 on the mixed practice. Okay. My next one I'm going to do is a lot like number 18 on the mixed practice. So number 8 is we are going to solve, and the problem we're going to solve is negative 3 times x minus 3 squared plus 6 equals negative 12. Lots of stuff happening here, so let's start undressing this x, if you will. Okay, so the first thing we need to do is subtract 6 on both sides. And so we're left with negative 3 times x minus 3 squared equals, and then that becomes a negative 18. And then we can divide both sides by negative 3, which is good because then those negatives can cancel and we end up with a positive number on this side, and that positive number is 6. And so now we can square root. And so we're left with x minus 3 equals plus or minus the square root of 6. And the square root of 6 does not simplify, okay? Now this is where question 18 gets really difficult because what you get on this side is really gross, okay? I'm sorry that happened. If there's one like this on the quiz, it's not going to get that nasty, okay? This is what a more typical problem like this would look like. But we're not done. We need to add 3. So x is equal to 3 plus or minus the square root of 6. And then that's where you would stop. All right. Okay. So the practice problem like that one that I would encourage you to do is negative 3 times x minus 2 squared minus 16 equals 2. Okay. That's what I would encourage you to do next on that one. Contact me for the answer. All right, let's do 2 more. I'm going to do number 9, practice problem 9, or sorry, example 9. And example 9 compares really nicely to number 22 on the mixed practice, okay? So this, I want you to solve 5x squared plus 15x minus 3 equals 0 by completing the square, okay? And the reason I chose this one is because this is an example of one where we're going to have to factor out an a value, okay? So when we complete the square, the first thing we need to do is take that 3 and put it on both sides. So we're left with 5x squared plus 15x is equal to positive 3. And then we have to get rid of that 5 as the a value out in front. So you take the 5 out, you're left with x squared plus, that becomes a 3x, and then we're left with a 3. Okay, so that's the first major thing that you got to remember to do when we are completing the square is get rid of that a value out in front. Okay, now we need to find that c value, and so we take 3, we divide it by 2, and we square it. Well, that becomes 9 over 4. Okay, so we have plus 3x plus 9 over 4 equals 3, and then we gotta wait on that side, right? And so we didn't just add 9 over 4 to that side, we added 5 times 9 over 4, and 5 times 9 over 4 is a really nice and pretty 45 over 4. Okay, now I need to find the calculator here, and this might get a little bit, not pretty, but that's okay. And so this factors over here, we still got that 5. This factors to an x plus 3 over 2 squared, okay? And then that equals, we do 3 plus 45 over 4, math, enter, enter. That becomes a 57 over 4, okay? All right, so now we solve for x. So we divide both sides by 5, and we end up with x plus 3 over 2 squared equals, okay? And if you do 57 over 4 divided by 5, I'm just doing it in my calculator, and then turn that to a fraction, that turns out to be 57 over 20. Okay? Now this is interesting. I don't think that something like this specific would pop up on your test, but let's walk through this, okay? So you square root, and so you're left with x plus 3 over 2 equals plus or minus, and then I'm going to go ahead and split it up to be 57 over, and then the square root of 20. Well, 20 can be broken down into 4 and 5, and 4 goes down to 2 and 2. So there's your pair, right? So this is really saying x plus 3 over 2 equals plus or minus the square root of 57 divided by, and then you can take a 2 out, and what's left is a square root of 5. Well, now we have a square root in the denominator that we need to get rid of. So we multiply by the square root of 5, multiply by the square root of 5. So now we have x plus 3 over 2 equals plus or minus, and 57 times 5 is going to be the square root of 285, and that does not simplify, so we keep it like that, over 2 times 5, which is 10. You would have gotten this same answer, by the way, had you just come up here and multiplied by the square root of 20, and then simplified, of course, okay? And so now all we have to do is subtract the 3 over 2, subtract the 3 over 2, and if I were you, I would leave your answer as negative 3 over 2 plus or minus the square root of 285 divided by 10. And then just stay there. Don't try to do anything wild and crazy after that. Okay? Things get messy, but it's okay. So practice problem 9 then would be for you to solve 2x squared plus 6x minus 3 equals 0 by completing the square. That one doesn't turn out to be quite as nasty, so let me know when you're ready for that answer. You can also check by doing the quadratic formula, by the way. Okay. Okay, last one. 10. We're going to solve negative 6x squared equals 10x by using the quadratic formula. Okay, this is just like number 26 on your mixed practice. Okay, so the first thing we need to do is set it equal to 0. I'm going to take this negative 6x and put it on the other side. So I have 0 equals 6x squared plus 10x. And then you can divide everything by 2 if you wish, or you could just go forward with the quadratic formula. So my a value is 6, my b value is 10, my c value is 0. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And now we plug and chug. X equals negative 10 plus or minus the square root of 10 squared minus 4 times 6 times 0, all divided by 2 times 6. And now we just clean it up. So x equals negative 10 plus or minus the square root of 100. And then this works out nicely because 4 times 6 times 0 is just 0. And then the bottom is 12, which then becomes negative 10 plus or minus 10 divided by 12. And now this is when you split it up into two cases. You have x equals negative 10 plus 10 divided by 12, and you have x equals negative 10 minus 10 divided by 12. Negative 10 plus 10 over here is just 0 divided by 12. So this one yields an answer of x is equal to 0. And then this one over here gives you x equals negative 20 over 12. And that is something that simplifies to negative 5 over 3. And you can check those using the graphing calculator. Okay. So the practice problem for this one would be for you to solve negative 3x squared equals 7x using the quadratic formula. I would highly recommend you do that one, and then let me know when you're ready for the answer. Okay. Hopefully that helped. I know it's a lot of just redundancy. Like you're like, Ms. Bachman, you didn't tell me anything there that I haven't heard before. Right. That's kind of what math is, you guys. Once you start realizing some patterns, you will realize that things really aren't that different. Okay. And so I would encourage you now to go through that mixed practice and take it as a test, rework some homework problems, rework some example problems, and really just find those patterns, because I really do think that once you find the patterns, you're going to find that it's a little bit easier to be able to solve really any quadratic equation. Okay? So good luck. Let me know if I can do anything for you, and I'll see you on Monday. Okay?